Okay, on this chapter, we're actually solving systems of equations using matrices, and we did not do this in Algebra 2. It's something that the district decided to not look at. But I want to, and I'm giving this in the order that the quiz goes, so I'm surprised they start with this and not the other way. But this matrix here is the same as the system of equations. So this is x and this is y. Systems of equation 1x plus 3y equals 10 and negative 2x minus 5y equals 12. So at some points mathematicians decided to just kind of abandon, if they can keep track of other variables by place, and we can most definitely do that, put that back, with matrices, then they just stopped messing around with the variables. So there's something called Gaussian elimination. And what that means is this matrix is going to turn into, we're going to do some manipulations on this matrix. So we get a 1 here, a 0 here, and a 1, it works, but we can get any number here. So the last number can be any number. And then, of course, we'll have other numbers here, here, and here. So we're trying to get a 1 and a 0, and you'll see how we can then back substitute. All right, so the way we do this is, first of all, I look at my matrix, and I notice that the first column does have a 1. So that's taken care of. Now what I want to do is do some combining, some eliminating, so that I can make this number a 0. All right, so how do we do this? And it's helpful to label these as equation 1 and equation 2. And it's just going to help you to understand what I'm doing. So I'm going to take equation 1, and I'm going to multiply it by 2, and then combine it with equation 2, and that'll cancel the negative 2 and give me a 0. So equation 1 is 1, 3, and then 10. And I'm going to multiply that, like I said, by 2. That'll give me 2, 6, and 20. And with that, I'm going to combine that with 2, which is a negative 2, a negative 5, and a 12. When we combine those, we get a 0, which is what we want, a 1, which is really nice, and a 32. So my matrix transforms itself into, and I'm writing this because it kind of helps us keep track of the work. It's also the way the book does it. And I have a hard time with the bar because it looks a lot like a 1, so I either make it another color or give myself extra space. So my first row is the same. My second row has been transformed to 1, 0, 1, 32. Now what this row means, and we're gonna back calculate starting with row 2. What this row means, if I write it out, it's 0x plus 1y equals 32. So I don't usually write that 0x. Usually I just start with the 1y. All right, so I know that y is equal to 32. Now I'm going to take the first row, which is x plus 3y equals 10, and I'm just going to substitute the y. X plus 3 times 32 is equal to 10. When I solve this, I get x plus 96 equals 10. Subtract 96. X equals negative 86. And those are my two solutions. And what I would do in your work is just do the work, box your solutions. Okay. Same idea here. This is a matrix that's representing your coefficients of x, your coefficients of y, and now the coefficients of z equals some constant. Okay? So I'm not going to rewrite this, but I am going to notice that, yay, I have a 1 in the first row, first column. So I'm going to use that row to get what I need out of the rest of it. So looking at row 2, what I really need, where that 3 is a 0. And the way that's going to work is I'm going to take row 1, I'm going to multiply it by a -3, and then combine it with 2 to get my new row 2. Okay, so 1 is 1, 1, -1, and 0. Like I said, I'm going to multiply it by a -3 so that when I stack it, when I combine it with row 2, it's going to eliminate the x's and give me a 0. And that gives me -3, -3, +3, and then a 0. And now I'm going to take 2. Actually, I'm going to stop with the arrows. I tend to overdo them. And combine. And I get 0, which is what I want, -1, and 2, and -1. Now, it's better. The nice thing here is that my next term is a -1. That's nice because I need it to be a +1. One thing I probably should have written is what my goal is. I need a 1, some number, and I'm just going to talk about the left side of this matrix. Here I need a 0, a 1, and some number, and here I need my third row, I need 2 zeros and some number. This is why it's called Gaussian elimination, because we're working towards that goal. And you'll see, kind of tell on the previous example, it works out quite nice. All that said, I am going to multiply this result by a -1 so I can get the +1 I want. That gives me 0, +1, -2, and then across from that bar, I get a +1. So rewriting my matrix, first row stays the same. And 0. And my second row turned into the result of my last calculation, 0, 1, -2, and +1. And my third row stays the same, but I've got to do something with it. What I'm going to do with it is I'm going to do a similar step to what I did with the second row, is I'm going to rewrite the first row, multiply it by a +2, and let's do that. 1, 1, -1, and 0. Multiply it by a -2, that way I'm going to eliminate, multiply it by a +2, that way I can limit the -2 in the first column, third row. All right, so that's my result of multiplying row 1. Now I'm going to bring down row 3 and combine. And I get 0. That's what I want. I get a 3 here, and I get a -4 and a -1. So this is better. Okay, but what I really need here is not a 3, but a 0. So what we do, and I guess I can write this one more time, 1, 1, -1, 0, 0, 1, -2, 1. Oops, I need to write my new row 3. Okay, now the way I'm going to eliminate the 3 in row 3 is to combine it with row 1. And I need some more room. So I'm going to do this work over to the far right. So, sorry, I'm going to combine it with row 2. Let me see if I've got enough room. So row 2 is 0, 1, negative 2, 1. And if I multiply that by a negative 3, give myself a little more room. And let's see if we can delineate this work. If I multiply that by negative 3, then that'll allow me to cancel when I combine it with row 3. So 0, negative 3, positive 6, and on the other side I get a negative 3. All right, so let's bring in row 3. And that is 0, positive 3, negative 4, and on the other side of the bar is negative 1. When I combine these, I get 0, 0, 2, and negative 4. So, let me see if I can rewrite my matrix one more time. I knew I'd have problems with the room, or finding enough room without making these problems huge. Zero, 0, 2, and negative 4. Zero, 1, and negative 4. Bit of a mess. All right, so when we get down to this last line here, this really means 2z is equal to negative 4. I'm going to write this on the right. 2z equals negative 4. This is why we want these 2 zeros here. Okay? So we are basically solving for one equation when we get the 2 zeros in the last row of these 3 by 3 matrices. So it looks like dividing by 2, z is equal to negative 2. Okay? Now we're going to work back. I'm going to go to my modified row 2, which gives me 0x plus 1y minus 2z equals 1. I'm going to plug in the z I just calculated. Y equals negative 3, and I need a little more room. So I'm going to grab the first row, which is x plus y minus z equals 0. Plug in my numbers. Y is negative 3, z is negative 2. And it looks like I get x minus 1 equals 0, x equals 1. And after a long time, I am done with that problem. I'm sorry this video went so long.